Okay, hi everybody. We're working through the diploma prep material. This is the chapter on trigonometry. And what I got to do is try to solve this equation here. And here's I got to solve it for the specific domain, and then I got to give the general solution is what this question's asking for. Now notice, first of all, I've got this cosecant squared here. This is a little awkward to work with. But notice that I don't know what theta is. And so as a result, I don't know what cosecant of theta is. This is basically just a big old unknown to me. So I'm going to replace cosecant with x. And so then what I can do now is just focus on the algebra part of this first here. So bring the 16 over, divide by 4, and I get that x is equal to plus or minus 2. Okay, so now that I've isolated the x, now what I can do is I can plug that cosecant back in. Okay, and I know that cosecant is the reciprocal of sine. So if I reciprocate this, I will get sine of theta, but I got to reciprocate the other side as well, and I get plus or minus 1/2. Now that plus or minus is significant, okay, because that indicates to me all 4 quadrants. So I'm going to be getting answers from all 4 quadrants. Now I got to go up and look at my domain, which was 0 to 360, because I got to know how many times I go through some of these quadrants here. But in this case right here, the domain is actually a fairly straightforward one. We just start at 0 and we go around 1 full rotation. We have got representatives in all 4 quadrants, which is great. We're only going to get 1 angle for each. So really what I got to do now is just find the inverse sine of positive 1/2 to get the reference angle. And it turns out, again, we're in degrees. This is quite straightforward. I can either use my calculator or I can just think back to my unit circle. I know it's 30 degrees. And so now I just got to put 30 degrees in all 4 quadrants. So in the first quadrant, that'll be 30. In quadrant 2, that's 150. In quadrant 3, that's 210. And in quadrant 4, that's 330. Okay, now the general solution. Now, I'm going to get a little bit lazy with the general solution here because I want you to notice something. Notice that this angle right here and this one together form a single straight line. Just like this angle right here and this one, again, their terminal arms form a single straight line. The reason that's significant is because if they form a single straight line, then the 2 angles here, those 2 angles, for example, right there, they differ by 180 degrees. And likewise, so do those 2. So to get my general solution, I can kind of get a little bit lazy with my notation. What I'll do here is I will pick a representative for the first quadrant, first quadrant and the second quadrant. So the 2 angles that I got for those are 30 and 150. And to build the general pattern here, I'm not going to add 360. What I'm going to add is n times 180, where n is an element of the integers. Because what that'll do is that'll help, I'm starting with the first and second quadrants, but if I'm only adding 180, add 180 to this one gets me down to the 3rd quadrant, adding 180 to this one gets me down to the 4th quadrant, and then the pattern repeats again. So those are the specific solutions in the domain given, and this is going to be enough to represent the general solution over the entire domain.